Hi, welcome back. As I promised, we're going to be taking a look at some more examples with chain rule. So let's go and take a look at number 8. Now number 8 looks like number 7. We have this weird power on the inside here, and that's what we have here. We have this cosecant squared. The first thing we do, we don't like the square right here, so we are going to, again, just like number 7, rewrite this. And that's going to become f of x equals the cosecant of 3x squared squared. And this one's going to be a little bit more fun for us because if you notice, if we look at our nesting doll here, we have an outside function which is a square. We have an inside function which is a cosecant, but notice we have another inside, that's 3x squared. So if we go back up to our nesting doll example, we have our outside, we have an inside, and we're going to have another inside. So what do you think we're going to be doing here? Yeah, you're probably right. We're going to take the derivative of the first outside, multiply that by the derivative of the second inside, and then multiply that by the derivative of our second inside. And it's going to keep multiplying here, and we keep going this forever. So let's look at our example here. So to take our derivative, I'm going to give myself a little bit more space here. You'll see why. When we take the derivative of the outside, we're only looking at this quadratic here. And we're going to drop that power, and that's going to give us 2 cosecant 3x squared to the first. I always put a 1 there. I don't need to, but I should. When we do the derivative of the inside, that's this cosecant. So when I take the derivative of this inside, now we're looking at our chain rule. This becomes negative cosecant 3x squared times cotangent 3x squared. Remember, the derivative of cosecant is negative cosecant cotangent. But I'm not done because I still have this other inside. So I'm going to do my chain rule again. And now I see why we call it a chain rule. We are just adding a link to the chain. So I got a chain rule here, and I just do it again. And that becomes 6x. The derivative of 3x squared is 6x. And you can clean that up a lot if you like, but don't. We'll just leave our derivative as such. If you get one like this, and you can do it, you're doing really good. That's a really good problem right there. All right, number 9. All right, number 9, we actually have 2 ways to do this one. One, we could use the quotient rule on this one, but that gets pretty nasty for us. So another way I could do this, because this is just a coefficient, in other words, there is no variable. If there is a variable, we're going to talk about that one tomorrow. I could rewrite this as negative 7, 2x minus 3 to the negative 2. I'm just going to bring my power up. And now when I take the derivative, now it's just chain rule. My outside, if I bring down that negative 2, we're going to get 14, negative 2 times negative 7. The inside, remember, stays the same. But when we subtract our power, we should get a negative 3. Be careful. Multiply that. Don't forget your chain. Multiply that by the derivative of the inside, which is just 2. Now, we do have a slight issue with this one because we have our negative exponent there. Remember, we don't like negative exponents. So when I rewrite it, think about what goes on top and bottom. The 14, it will stay on top, but I'm going to multiply it by that 2. So I can just write this as 28. If you want to leave it as 14 times 2, that's okay. On the bottom, we're going to get this 2x minus 3 cubed. Chain rule is going to help us do this one a lot simpler later on. There we go. There's our chain rule. Now I know what you're thinking. Mr. Warnow, these stuff are pretty cool. But how's it going to help me with my tangent lines? That's a good question. So let's look at a tangent line problem now. We want to write the equation of the tangent line at the given point. Well, we know what we need. One, we need a point, which they're giving us, 3, 5. We also have to find the slope, which means we need the derivative. So we're going to rewrite this one. I'm going to write this as y equals 3x squared minus 2 to the 1/2. Now, because they're using y, I probably should use y prime or dy dx. It doesn't really matter which one you use. So when I take the derivative, this is my chain rule. My outside becomes 1/2 the inside stays the same. And when I subtract 1, we get a negative 1/2 times, now we have to do the derivative of the inside. This is our chain part. The derivative of 3x squared is 6x. So my derivative, if I were to clean this all up, we would get 2 on bottom and this 3x squared minus 2 to the 1/2 and the 6x on top. Alright, to get the slope, we want to plug in our x coordinate at x equals 3. We would get 6 times 3 over 2 times 3 times 3. Oops, sorry, 3 times 9, sorry. It's 3 times 3 squared, so 3 times 9 minus 2 to the 1/2. And that becomes 18 over 2 times, well, that is 27 minus 2, which is 25. Square root of 25 is 5. So we get 18 over 10. There's your slope. All right, I didn't leave myself much room for the tangent line. Wow. Okay, so let me go and write it right over here. Ready? Y minus 5 equals 18 over 10, x minus 3. Yeah, I did not leave myself much room for my actual answer there. But there we go. There we have it. There's your tangent line. Woohoo! So easy. All right, let's take a look at number 11. Oh, no. I know what you're thinking. It's pretty tricky. We need a point. They give us a point. Pi over 3, negative 2. Next, we need our slope. I'm going to give myself a little bit more room here. To get the slope, we need the derivative. I should use y prime again. Keep messing that up. There we go. Try to use whatever variable they're using when you write their derivative. So we get y prime. Notice over here I use dy dx. Here I'm just using y prime. It's the derivative. All right, so let's see here. 2 is just a coefficient. I'm not even worried about that, man. That doesn't bother me. 2 times, now here's my chain rule. My outside is cosine, which becomes negative sine of 2x times my inside derivative is 2x, and this derivative is just 2. So I want to find the slope when x is pi over 3. 2 times negative sine, that becomes 2 pi over 3 times 2. All right, and if I multiply these together, that's just going to become 4 negative. So let's see, what's the sine of 2 pi over 3? Root 3 over 2. And if I simplify that, I get negative 2 root 3. And there's your slope. So my tangent line, y plus 2, be careful of your sign, negative 2 root 3 x minus pi thirds. And there's our slope. Man, every time. Look at that. Pretty easy to do. Guys, you guys are going to rock this, okay? This is easy. This stuff's easy. All right. Take your time if you need to. Watch the video again if you need to get this stuff again. Go put me on half speed if you need it. All right, so now let's take a look at analytic derivatives. Again, this is what the AP likes to see. You're going to definitely see something like this on the AP. When they say h of x is equal to f of g of x, you want to find h prime of 3. Ignore all this for now. I just need to take the derivative. This is classic chain rule. H of prime of x. My derivative of my outside is f prime g of x times the derivative of my inside, which is, remember, this is my chain part, g prime of x. There's my derivative. There's my inside derivative right there. That's it. There's your derivative. Now we're not done because we want to find h prime of 3. Remember, you need this. You have to show this for the AP exam. To get h prime of 3, ready? Now we're going to plug it in. F prime g of 3 times g prime of 3. So let's simplify this. I can do a composite. What is g of 3? They tell me it's 4. So we want f prime of 4 times g prime of 3. Well, what is f prime of 4? If I look it up, they tell me that's 8. G prime of 3, up there it is. There it is, negative 5. Oops, that's terrible. Negative 5, which becomes, of course, negative 40. And there's our answer. Piece of cake. So easy. Caveman can do this. I hope you guys enjoyed the video. Smash that like button, and I'll see you guys tomorrow.